Everybody, good morning. So my KDU this morning is about PHP unit testing. So before we start PHP unit testing, so let's just get a little bit of what testing is all about. What's testing? So this definition is the definition of software testing according to. So I'll just read this. Software testing is an investigation conducted to provide stakeholders with information about the quality of a software product or service under tests. Software testing can also provide an objective, independent view of the software to allow the business to appreciate and understand the risks of software implementation. The techniques include the process of executing a program or application with the intent of finding software bugs, error, or other defects, and verify that the software product is fit for use. So when you test your software, you want to test it from the business perspective and from the functional perspective to see if it is working and if it is fit for use. So that's what software testing is all about, just to know if your software is good enough for production. So two of the most common ways to approach testing as a user and as a developer are the white box and the black box testing. So if you are testing a software, you can test it in two ways. You can test in the black box way and in the white box way. So for QA, quality assurance person, what they do is they test in the black box way. In the black box way, you don't have access to the code base. All you do is you are given a solution, and they tell you that this solution is supposed to allow you to make a call. That's in the case of phone. So you don't know what code is behind making a call. All you know is that this is what the solution is supposed to do, and then you pick it up and you try to test it. So that is for quality assurance officers doing tests in black box. But for white box, that is done by developer. They have access to the code, so they can do the test, and when they test, they can, when there's an error on their own side, they can immediately look into the code and see what's causing the error and make modification if necessary. While on the other hand, for the white box testers, when they find error, what they do is they report the error, and then after that, even the developer has to do a whiteboard test to confirm what is happening and also fix the error. So we have different test levels. We have unit tests, integration tests, end-to-end test, and acceptance test. So unit test, which is the topic of this KD, is a fast, low-level test with small footprints written by the developer to test stability of isolated units of code. So unit test, what you do is you want to test like small fragments of code, something as small as a component, something as small as a module, something as small as a single function, something as small as a single class. You want to test to see if it is behaving the way it should. If it is, maybe for a function, you want to test something as simple as you expect it to return an array. Is it returning an array? You expect it to return an array of this count for this set of inputs. So you simulate the input, and then you expect it to check the count of the array to see if it is exactly what you expect. You expect the array to contain this type of object. You simulate for this set of inputs. You simulate the input, then you check it to see if it is actually return what is expected. Integration testing, verifying if and how two or more components or modules interact, talk to each other. So for this kind of testing, it can be done by the QA testers and it can be done by the developer. So integration testing is you have two components. At some point, you expect that this component should communicate. Now, after the integration, then you want to test if these components are actually communicating. Okay, from a functional perspective, for a function, the code function perspective, you have a code calling another code. Then you expect that this code does a lot of complex things. Then after the complex thing, you expect some kind of values to be set in database. Now, from the developer perspective, then for integration testing, you want to check if what the other function have done on behalf of this function is correct. Then you are doing an integration test. And for the QA perspective, all you want to do is you want to say, okay, a developer has given me an application that when I send when I send a message, the message is supposed to go to a point where the message is delivered. Now you are integrating two solutions, a solution for sending a message and a solution for delivering the message. So the QA wants to see if you send the message and then the other point got it, then now you are testing the integration of the two solutions. That is from two perspectives. From the developer perspective, it is more low level, but from the QA perspective, it is quite close to the next type of test that we'll be discussing, and that is system test or end-to-end testing. This is a complete test of the system. When unit tests and integration tests are testing parts of the system, this one is testing the system as a whole. Now you have the whole system. Then you want to test the whole system, the whole functionalities. It is best done by the quality assurance tester. For example, an example of an end-to-end test is a user creating a cache request up to the point where the admin reconcile the loan. So we want to confirm if the cache request was created, if the cache request go through the right flow, if message were sent at appropriate points during the cache request flow, and if the and at the end you want to check if the admin was able to reconcile the loan. So you want to check the whole flow of the system. So this is done from user perspective and shouldn't be automated with data mocks or fake requests. So when you are doing an integration test, you can't use test data. You probably want to use real data, and so that you can behave as if it is a real world scenario. So if you discover a bug in your integration test, then you want to recheck your end-to-end test. Then after that you want to go back to your unit test. If you only get issues in your integration test if something is wrong with functions, with modules. So at the end of the day, if issues occur with integration tests, you take step back to the lower level of the test. So next we have acceptance test. So this is a test from a quality assurance perspective and a business perspective. So in this kind of test, you want to check if this test is actually acceptable. So generally you have done the test. Now you want to say, okay, we expect this solution to provide this function, this function, this function, this function. Does it provide the function? Does it provide it appropriately? Can we now say that this solution is ready? Can we now send it out? Or if it is a case of delivering it to a client and we now say the solution is ready, it contains all the expected function, then it is acceptable by the client and we can deliver. That is acceptance test. So I'm going to discuss a test strategy that is very applicable to unit testing. It is called test-driven development, short as TDD. TDD is a software development process that relies on the repetition of a very short development cycle. First, the developer writes an initial failing automated test case that defines a desired improvement of a new function. Then the product proceeds to minimum amount of code to pass the test, and finally refactor the new code to accept standard. So what this is saying is when you are developing in TDD, in test-driven development, you think about the test first before you think about the code. Now, the way solutions are created is there's a problem. Okay, there's a problem that says we want this, we want this, we want this. Now, before you write the code, you write the test first. Meaning the solution is driven by the test. You first write some set of code to test if these things are happening. Then after that, you write the code to make it happen. Then after that, you go back to test if it is working. Then after that, you go back to the code to modify the code to modify the code to make it better. Then you come back and ensure that test is still running. Then after that, you move on to your next functionality. For your next functionality, you write test. Then you write code. Then you test. You modify. You test again. Then you move on to the next functionality. That is how you write. That's how you develop in TDD. So, okay, this will be a question. since TDD requires you testing your system, writing a test for your system before you even, okay, let me use the word right to be an it, creating a test for your system, ensuring that you have something that will catch your system if it is not working fine before you even develop your system. Comparing the four type of tests we have, okay, let me say the first three because the last three is not applicable in this case. Then we should be able to say which kind of testing will be applicable to TDD. Now, if you look at it, I'll just answer the question. It is unit testing, and the next slide you say why. This is called the test pyramid. The test pyramid shows, it shows each level of test, the number of time, the time and effort that we put into each level of test, and the number of tests, the number of tests we should have for each level of test. Now, if you look at the pyramid, it shows that for unit tests, it takes little time to create unit test and little effort. Why? It will take little time because you are testing something as small as a function. For you to write something to test a function, it will not take time because you know what you are expecting it to do. You just say, okay, this code, check if it is doing this, check if it is doing that, then you can move on. And little time is quite similar to little effort. Then for integration, you need to test if a lot of functions work together. If you want to write a test for that, it will take more time and it will take more effort. Now, for end-to-end, you may even need to, for end-to-end testing, you may even need to have people sitting together to do end-to-end testing. So that will take more time and take more effort. So now this implies that you should have in your system, you should have more unit tests, then more integration tests. Then what I mean is you should have more unit tests in your system. You should do more unit tests in your system rather than integration tests and end-to-end tests. So when writing unit tests, make sure assertions are running. Start with failing tests and then work on the test to make it pass. So that is just a review of how unit tests work. So you write your test, you write the code to make sure that, then you write the code, make sure assertions are running, then go back to modify the code, then come back to make sure assertions are running, do that for the next functionality, and you go on and on to complete the solution. But unit tests does not mean you don't have to do integration tests and end-to-end tests. They all have their place in the test process. So now, PHP unit test. So PHP unit test is a programmer-oriented testing framework for PHP. So obviously, unit testing is programmer-oriented. You cannot say a quality assurance officer to come and do unit tests because it's involved writing code. You probably don't want to write code even if they can, because they are not employed to write code. So to set up unit tests on your system, all you need to do is set up your project. If it's a new project, setting up a project for PHP can be as simple as creating a folder and give it the name of your project. Then maybe if you are putting it on XAMPP, you now want to put it on XAMPP, you now want to put it on this, or what server you are using in your local, or even if you are setting up a test environment on a remote server, then you want to do that. But setting up your project for unit tests can be as simple as creating your project folder if you are starting and you are integrating unit tests immediately for TDD. Now, after creating your project folder, then you need to ensure that you have Composer. If you don't have Composer, you can install Composer from Get Composer. Then after that, then you need to say Composer require PHP unit. So this will make Composer add PHP unit to your dependencies. So you have PHP in your vendor, so you'll be able to run PHP unit code. Then after that, you create a test folder in the root directory. So you have your project. Let's say your project is social lender. Then in the root directory of your project social lender, you have a folder called test. This is not strictly like that. There's a way you can change it and write configuration to say this is how you want it. But by convention, you want to have that folder test. Then inside your test, you can have different type of tests. So because we are doing unit tests, then inside the test folder, you want to create another folder called unit. So unit folder is where your unit tests will be. Then after that, you want to configure your environment. For configuring unit tests, you have to create you have to create a file called phpunit.sml in the root directory of your project. Then your configuration will go into that file. Then I'll show you an example of the file shortly. Then next, you write your test. You start writing your test. I'll show you how tests are written. Then you run your tests. So this next slide shows an example of a simple configuration file for unit test. So it's in two slides, this and that. So here you make some configuration like color. This says color is true. Color is true means that when you are running the test, you want unit test to show color to help you see what is happening in the test more properly. Convert errors to exception is true. So you want to see when an error occurs in your code, then PHP Unit Test to help you convert it to exception and show the exception. Convert notice to exception, same thing, then warning to exception, then stop on failure. This means that if PHP Unit ever encounter a failure, maybe you have 10 tests and it got to test 5 and test 5 fail, you want to say don't bother running the other tests, just stop. If that is true, then verbose means you want more details or not. If you want more details, want your test to be giving you more information about the test, more information, then you say it's true. Then if you just want minimum information, then say it's false. So this is the conclusion of the same file. The next, we see a sample test. So this is an example of a PHP unit test. So today, PHP unit test, this is according to unit test, PHP unit test 8.1. For other tests, you need the file, the class will need to extend the different. So to write a unit test, what you do is you create a file, a test file. Okay, let's say you have 3 classes you want to test. For each class, you can have a test class for each. So for this sample, we have a class called sample. That's an assumption, but that is not in this case. Let's say we have a class called sample. Then the test for it will be sample test. Let's say we have a class called cache request. The test for it will be cache request test. Now, the test class have to extend test case. Once a test class extends test case, this is how PHP unit test. We know that this is a class for testing. Then your test is done to function. So for every test, you want to write a function for it. Now, this is an example that says test true assert to true. It's an example. This is just to test if true is actually true. But this is saying true equals to 1. But this is actually testing if 1 is true. But this should have been, this was assert true equals to true. So for this test, if it was a case of a cache request, you can say test cache request creates successfully. Then you can now write code to test cache request. So what happens if a cache request is created successfully? So you can write some code to say cache request is no cache request. Then put values for the cache request and say save. So when you say save, one of the things that will happen is a new cache request is created and then the ID property will not be null on save. So you want to say this dot assert cache request dot property not null. Or you can even use assert true because true is false. Then by that you can test if a cache request was created successfully. So this is an example of a test for a sample test. Now to test, what you need to do is go to your root directory and run this command, vendor PHP unit -PHP unit. So for this command, you can create an alias for it. So you can create an alias that says alias PHP unit test to run vendor PHP unit. Based on observation, before this page started, this command did not run on Windows. So there's probably a different way to run it on Windows. But my system, this is it. And online us, this is how it works. So now we are supposed to have a test-driven development case using PHP. So the problem we are going to try to do is we are supposed to create a class and then use test-driven development to use test-driven development process to create a class. So basically, what we are going to do is we have some set of functionalities that the class is supposed to have. Then we are going to write test case for each functionality. The test case will be failing, and then we write code for it to pass. Then we test. Then it will pass. Then if it is required, you can refactor the code, then test again and ensure it still passes. So this is the problem statement. we create a class called collection. So collection, if you use frameworks that create a collection class, is a much better way of handling array. So what they do is they take array and put it inside the collection class, and then it allows them to write more custom functionalities that array does not have. You can even write functionality that can allow you to run codes that are similar to SQL on an array. Then you can start writing select from an array like that. So what we want to do is we want to create a class like that with this functionality. So functionality one, we should be able to create an empty instance of the class. The class is called collection. It means it has a collection of array. Now an empty instance of the class should create an instance of the class with with nothing inside the array, with nothing inside it. Then we should be able to create a non-empty instance of the class. So this means when you are creating an instance of the class, we should be able to instantiate it with a list of elements for it to start with. Then we should be able to pass items. Okay, we should be able to ensure that when we create a class passing items, the items passed to the class are correctly set, which means, okay, we can create a non-empty class, a non-empty instance of the class, but are those items correctly set? So we can go on and say, okay, is this item set? Is this set? Is this set? Then after that, we should have object of the class must be an instance of iterator aggregate. So iterator aggregate is an interface in PHP that allows your class to behave like an iterator. An iterator in the sense that you'll be able to look through it. You'll be able to use the feature for each on it like it was an array. Then the object should be iteratable using PHP for each. So if you are using an iterator aggregate, there is a particular function that your class must implement so that you can use for each on it. Then we should be able to add more elements to the object. So if you have the objects, the class and the collection object set up, you should be able to call, say, function add to add more elements to it. Then you should be able to match two collections together. So you have collection A and collection B. You should be able to merge it as one collection. So that's what I'm supposed to do next. So this is supposed to be a demo session, but because this system can't run the tests currently, so I'll just be showing you what steps we should have taken to do that. So I'll be bringing up the code for the test. So this is a sample project. The project name is PHP Unit Test, and we have the test folder. After running PHP Composer, after running Composer require PHP unit, then you have a vendor code automatically created for your project. You can also use it to add other dependencies that is required by a project. But if you are using a framework, it automatically comes with it, so it won't create it on the first time. So what you probably want to do is to run updates for it to download it. So then we have the test folder in the root directory, and then inside the test folder we have the unit test. And the unit test contains, or the unit test folder contains all our tests. So this is sample tests. Okay. I would have loved to run the sample test for us, How do we do that? Okay, so let's just go to our collection test. So for our collection test, we are supposed to create a collection test class. So what I'll do is I will uncomment collection test class. For a test, you have to use PHP test case. So this test case class your, for your for your test class to extend. So before we can say, like I explained earlier, before you can say this is a test class, your test class will extend test case. This is according to 8.1. In older version, the class we need to extend is different. Then after that, so let's this now our first scenario said you should be able to create an instance of the collection class without without any without element passed to it. So what we do first is write the test to say okay, we should be able to do that. So this is the test here. The test says function test empty instance. Empty instance initiated collection returns empty collection. So what you want to do is you want to create a new collection class. They want to say assert empty collection.get. So this shows that our collection class shall have a get function that will return all the elements of the collection. And then when you create a new collection class, this whatever this is returning to be empty. So now, what is assert empty? So assertion is what you do when you are doing unit test. Assertion means, is this true? Is this truly happening? So when you are writing unit test, what you just do is a series of assertion. You assert this, you assert that, you assert this. Then if all your assertion pass, then the test pass. Now, this shows that this also shows that we need to have a collection class. Then we need to have a get function. So now, if you run this test initially, it fails. It will fail. It will tell you if you tell you like no collection, no try to create instance of the collection, or it will even tell you cannot find collection class. So what we would do for it to pass is to create the class and create the get function. So here, I would have loved to run the test for you to see the error and then see what we do to solve it. Now we create the collection. And then create a constructor and then create a function to say get. So now after writing this code, the test will pass. Why? Because we have a function get that will return this as item. This as item should be an array, and on creating a new instance, we run a constructor, and the item is an empty array. So by the time it's getting to that test, it has an empty array. So the test will pass. Now the next thing to do is, if you run this, the test will pass, then you go on to the next functionality. The next functionality says you should be able to create an instance of the collection with elements that is not empty. So what you want to do is you want to write another test. You say, now we are creating a new instance of the collection and we are passing elements. We are passing elements to it. So what happens? We want to now check if the elements is equals, if the number of elements in the collection is equals 3. So now we want to take the collection, we want to count what is inside. It means we need to implement the function count on it. We could have used we could have used get elements. There are various ways you can do this. You could have used the get element to return an array, then use the PHP count on it. We could have also say we could have declared this and then test if it is same. Assert if it is same as what, just use get and assert if what is returned is the same as this. So now we are going to implement the count function, and then we are, so now you go back to your code. The new feature is to count. Since you have the count function, your test is going to pass. Then you continue like this for every case till you complete the function, the feature you are trying to build. So now, as we have seen, what unit test is about is creating assertion, creating features, and creating assertion. These are true. That is how unit test is all about. But now, from the demo, what we have used is we have actually used two assertions. We use equal and count. We use equal and count. There are hundreds of assertions in PHP unit test. Hundreds. There are assertions to test if an instance, like in our problem, we have a section that we want to assert if what collection is an instance of aggregate. We have something to assert if it's an instance of. So there are hundreds of assertions. So if you want to learn more about PHP unit test, then you can check the official documentation here. You also have other features like test data provider. Before you run collections, you can define the data provider for a particular test. A test, in the sense, it means a particular test function. You can say before it's run, get data from this place. You can also write tests that will be dependent on each other. You can say a test is dependent on this, and say before this test run, first run this test, then get the output of that test, then come and use it here. That is also possible. Then you can use setups. Setup means you can write a function called setup that will run before every test. That is good for if you want to initialize something for every test. Like say you are testing a user functionality, and then you say before this user functionality test starts running, please create an instance of a user and say this dot user. Then you can use it all through the test to be testing this. And you can also set things. You can even do global settings. Maybe change the database you are using for this particular test. Maybe you don't want to use your live database. Then you can also write tests. You can also handle errors in your test. So you can see more of this on this link. This is for 8.1. There are other versions. Okay, going to the next slide. So now I just want to show how PHP unit test relates to everybody know why I'm saying it. Now this is also the same thing for so many other frameworks, Laravel for instance. But in the case of V, this is exactly how it works, but it may be slightly different in the case of say Laravel or Code Igniter. For Laravel, the difference is not so much. Now for Yi PHP unit test, E1 or E2, but this is specific to E1. PHP unit test is built on top. Yi unit test is built on top of PHP unit test. So what that means is every assertion, everything you can do with PHP unit test, you can do with Yi unit test too. Exactly everything. If you have the documentation, only that you have to ensure that for E1, you have to ensure you have the correct version of the PHP unit test that E1 is using. So now what happens is when you are creating tests in PHP in Yi, what you do is you extend C test case and CBB test case. Now, C test case, you extend it in, like remember when we were creating our test, we extended PHP unit test. Now, in Yi, you extend C test case. Now, you extend C test case if you are just running tests on model, on normal model that are not related to database. Now, if you are testing collection on active record are model that have database relationship. What you do is you extend CDB test case in case of active record. Then with that allows you to use everything related to PHP unit test, because these two functions extend, they are actually parents, they are actually children to the PHP unit tests. So PHP unit framework test is the ancestor of both classes. Now, when you want to write tests, exactly the same way we have written it in PHP unit test, you start by saying XYZ test / quest test. Then for function, you want to create test create that request successfully. Exactly the same way you have done that. And that is how PHP Unit applies to you after that. Thank you. Any questions? Any questions?
So, in JavaScript, you have suits like Mocha, Chai, and others for testing. You have things like that in PHP or the language that takes care of some testing.
Okay, for testing, that is what we have installed, PHP Unit Test. So like Mocha is for testing on JavaScript. So what you do is npm install Mocha. So that is why we have done composer required PHP Unit Test. So PHP Unit Test is like Mocha for PHP. So it's the testing framework for PHP. There are a lot of things you can do. This is just like the scratch of the surface. There are really advanced things that you can do with PHP Unit Test, like you do on Mocha. Okay, thank you.